Hey, welcome to Understanding Gradle. In this episode, we'll look a bit more at how test reports are generated with Gradle and how you can configure Gradle to also generate code coverage reports. In our example project, I have now added tests to both the data model and the business logic project. As explained in the videos on testing and configuring the test task, we can run the tests in each of these projects using the test task, and then we'll get reports in the corresponding build folder. So if we run the test task of the data model, we get a test report in the build reports folder, showing us which tests were successful and which failed and the corresponding failures. Running the test task in the business logic project, we get a similar report for the tests in the business logic project. Now these reports are directly generated by JUnit. There's a binary version of the report data that can be picked up by some tools like Jenkins, for example, and there's an HTML version rendered by Gradle. I've already shown, when we talked about configuring the test task, how you can influence which reports are generated and where these reports are placed. We perform such configuration in our base convention plugin. Now another report you might want to generate is a code coverage report. Such reports tell you which parts of your code have actually been touched by your tests. For this, you need additional tools. A common tool in the Java world is Jacoco, the Java code coverage tool. Gradle Core directly supports this. If you want this report, as typical with Gradle, you apply another plugin, which in this case is called Jacoco. This plugin actually extends the functionality of the test task. If applied, you get an extension where you could configure some details, but you can also just roll with the defaults. So only applying this plugin already gives you code coverage reports. With the plugin applied, run the tests again. In this example, in the business logic project, we can see how an additional report has been generated. It shows us which parts of our code has been touched by our tests. We could generate the same report now in the data model project. Imagine now that you have a larger real project. In these cases, especially the code coverage report is something that you often would like to see aggregated. So you don't want to look at like 50 different reports, but want to have one single report that shows you all the code coverage of your complete code base. And similar, also the normal test report you might want to see in an aggregated view. In the video about aggregating custom artifacts, we already talked about use cases like this. There we explored how you can generate an aggregated Java doc of your complete code base. In that video, we used variant-aware dependency management features like consumable and resolvable configurations, because that's something where Gradle does not offer a direct solution out of the box. For the test result or code coverage report aggregation, we could do something similar. But since recent Gradle 7 versions, this is supported more directly by Gradle, by offering plugins that do most of the setup for you. Always when you aggregate something, you need to decide in which project this aggregation happens. So for the Java doc, we picked our app project to do the aggregation there in the other video. This is a good choice in a setup like ours, because the app project is a place where also all the code is aggregated. So the app project already has dependencies to all other components of our software. So if we want to collect some report or verification data from all of our projects, we already have a dependency setup where all these projects are reached through the dependency graph. So in a project setup like this, we can now go to the convention plugin for our app project, and there we now just apply two additional plugins, the test report aggregation plugin and the Jacoco report aggregation plugin. Without doing any further configuration, Gradle can now provide us with aggregated test reports and aggregated code coverage reports. We can see that additional tasks have been added to the app project in the verification group. Calling one of these tasks will generate the corresponding aggregated report. This will also automatically trigger the execution of all the tests, because the report data is output of the test task. So typically, you might want to wire these tasks into one of your lifecycle tasks now. For example, the check task. The aggregated report can now be found in the build folder of the app project. For a pretty standard setup, this might already be sufficient for your build. And so with these new plugins by Gradle, the setup is rather straightforward. Still, you might want to do further customization, and then you quickly get to a point where you need a better understanding of what's happening in the background. One situation where you possibly want to customize things further is when you have tests in multiple source sets. In the configuring testing video, we used integration test as an example of an additional source set or an additional test suite. So for example, if we would configure an integration test source set with the corresponding integration test suite in our base convention plugin like this, then we would get an additional aggregation task in the app project for integration test reporting. So the integration test reporting, both normal test reports and code coverage, is completely separated from the test reporting, which is about the tests in the test source set only. A customization you could do now is to also combine all these reports into one. The use case would be to get the code coverage of all the combined tests. For this, we can, for example, go and extend the inputs of the test code coverage task, the one that for now only looks at what's happening in the test source set, to also include the integration test execution data. The execution data is something the Jacoco tool generates. The test code coverage report now is configured to take all the code coverage data that comes from the tests in the test source set. We can add more data here, because test execution data is an input of the task, and we can find that there is a configuration called integration test code coverage report execution data. This is set up by the aggregation plugins where all the execution data of the integration test is collected. So we add this as an additional input here, and one thing we need to tweak is that we need an artifact view with lenience set to true, because otherwise, with the dependency setup we have, Gradle would also look for execution data in external dependencies. For more details on this, check out the video about aggregating custom artifacts. With the setup, the test code coverage execution data task will now trigger the execution of the test and the integration test tasks and collect all the coverage data from all the test executions. But this is only one example of how you could customize the setup given by Gradle. The aggregation plugins we applied here are only convenience. They use public Gradle API to do all the setup they are doing. So as with other concepts like feature variants, these plugins just make it convenient to get a working solution quickly for most cases. But internally, they also only use public Gradle dependency management APIs. So all the things the plugins do is something you could do step by step yourself in your build scripts if you want a very customized setup. In the video about feature variants, I demonstrated this on the example of feature variants. If you get into a situation where you want to do such customizations, there's another help task I would like to show you that can help you. This task is called outgoing variants and can be found in the help task group. If you execute this task on a project, for example, the business logic project, you can see all the outgoing variants of this project. An outgoing variant is technically the same as a consumable configuration. So if you add a consumable configuration, you will get a new outgoing variant. And these are all the things that a project exports that other projects can then pick up. For example, here we can see that the project now has a variant that exports the source code of the project. This is something we added manually when we wanted to aggregate Javadoc in the aggregating custom artifacts video. For more background about all of this, have a look at my video about declaring dependencies and my video about aggregating custom artifacts. This video should give you a quick start if you wonder about how to set up code coverage reporting or tweak test reporting in general with Gradle. The topic is also another example of aggregating artifacts with Gradle, so you can explore it to understand the topic more. On the other hand, if you want to do more specific customizations, you need a bit of understanding of Gradle's variant-aware dependency management to tweak things for your custom requirements. If you enjoyed this video, please subscribe to this channel to get notified when new videos are available. In addition, you can also follow me on Twitter and check out the additional resources I'm linking here. See you next time.